3 of lesson 4.1. This particular video is going to focus on electric field strength and electric field lines. So this question right here says, what force will a proton experience in a uniform electric field whose strength is 2 times 10 to the 5 newtons per coulomb? So if we were to write out our yes method, our givens, well, we're working with a proton. We know that's positive 1 elementary charge, but that's also equal to 1.6 times 10 to the negative 19 coulombs. Remember, we can only use this coulomb formula, or coulomb units, when we use our formulas. So our givens would be that the charge is 1.6 times 10 to the negative 19 coulomb. Our electric field strength, which we denote as E, is 2 times 10 to the 5th newtons per coulomb. Our unknown is the electrostatic force. The equation that we would be using would be E equals Fe over Q. So clearly we are going to have to maneuver some things around. So let's substitute. So I have 2 times 10 to the 5th newtons per coulomb equals F of E, times 1.6 times 10 to the negative 19 coulomb. So in order for us to even begin, but let's make it two ratios equal to each other. So to make any number a fraction, I just put it over 1. And then from here we can do our cross multiplication. So I have this and this. So my answer becomes the electrostatic force is 2 times 10 to the 5th newtons per coulomb times 1.6 times 10 to the negative 19 coulomb. So if you do that in your calculator, 2 times 10 to the 5th times 1.6 times 10 carried to the negative 19, you should get an electrostatic force of 3.2 times 10 to the negative 14 newtons. Okay? So in this diagram, or in this question, it says in each diagram shown, an electron travels to the right between points A and B. In which diagram would the electron be deflected towards the bottom of the page? Okay, so we want to look for something that's going to get pushed down. Okay, so let's see. An electron, what do we know? Well, is attracted to protons. Electrons are repelled by other electrons. So let's keep that in mind. So if we go to choice A, right? If we apply this logic, well, it's going to be attracted to protons. So this electron is going to want to move upwards. But this question says it wants it to be deflected downwards towards the bottom. So A can't be the answer. Let's go to B. So it says that the electron is flowing in. I have negatives on the top and positives on the bottom. The electron would, in fact, want to go downwards towards the positive. So we'll keep that in mind. Let's go to C. C is talking about magnets that have absolutely nothing to do with what we're learning. And the same thing with D. So the only clear answer here is choice B. Okay? And just keep that in mind. Electrons are attracted to protons, and electrons are going to repel other electrons. So clearly, if you put an electron between two parallel plates, they're going to want to go to the positive plate. They are not going to want to go to the negative plate, so they get accelerated towards the positive plate. And that's very much identical to their charge behavior.